If I take you back to September 2020, like so many other grad students, my research plans have been turned upside down by the COVID pandemic. I was an aspiring marine biologist, back living at home with my parents, scrambling about to conjure up research I could do from my desk. But it was here I first started learning to harness something new. That was the magic of artificial intelligence. Now, don't worry, this isn't going to be a talk on AI chatbots, deep fakes, or how it might kill us all. Instead, I want to share something a bit more outside of the box that I believe is a unique example of how this technology might help save us from ourselves. To transport you on this journey, let's start by listening to something completely different. If you're like me when hearing this for the first time, then you might think that sounds like something from an alien planet. But in fact, what you just heard were all recordings we've taken from coral reefs. Just like the Amazon, these rainforests of the sea harbour diverse soundscapes, filled with the sounds of fish and other animals we find here. Reefs like this one host over 25% of all marine life, and some 500 million people are directly reliant upon them for their livelihoods. But it doesn't always sound like this. That was the sound of a degraded reef. Here, beyond that background crackle of snapping shrimp, the soundscape is much more desolate. All too often, those other sounds are missing. Right now, this is a growing phenomenon. The world's reefs are dying a death by 1,000 cuts from impacts like overfishing, pollution, and now climate change. In fact, we've lost over half the world's coral reefs in the last 70 years, and the outlook going forward is even worse. But there is hope. Literally. Pictured here is Hope Reef, the epicenter of the world's largest coral reef restoration program in South Sulawesi, Indonesia. Hope was built by the coming together of the Bontasua Island community, marine science grads local to Sulawesi, and industry giant Mars, the chocolate bar guys who lead this whole project. And they're now growing hope across the tropics, having planted more than 1.3 million corals over the last 15 years in 12 different countries. Now, restoring coral reefs is something that's still quite new. That means monitoring the impact of projects like Hope is pivotal in figuring out what works and what doesn't. The gold standard of monitoring is deploying expert dive teams into the water to do detailed visual surveys of what's on the reef. But this is a process that's costly, logistically challenging, and these experts are few and far between. But perhaps this is where listening to the reef can help. In my hand is an underwater audio recorder. Small devices like these can go for much longer than any dive team, recording data for weeks or months. And better still, it takes just a moment to jump off the boat and place a device like this onto the reef, meaning in a day or two, we can scatter these across areas it could take dive teams weeks to survey visually. This is exactly what we did on our first visit to Hope. With the recordings we gathered, our expedition lead, Tim Lamont, showed that we could track restoration progress by counting the animal sounds we heard within these. This was a brilliant proof of concept. But there was one big drawback. It took an age to listen to even a fraction of our data. A single hour of audio could take all day to analyze. So, you might now be realizing This is where AI starts coming into the picture, bringing us to that story I opened with, where, locked away during the pandemic, I took the time to dig out an old assignment from my undergrad. In this, we trained something called a machine learning model to predict whether patients should be diagnosed with heart disease or not by combining a range of different health measures. Now, I'll be honest with you, this was genuinely one of the worst grades I got that entire year. But I went back to this because I realized it wasn't too dissimilar to what we were now trying to do. But instead of blood pressure or cholesterol levels, we had audio recordings. And instead of patients, we had coral reefs. So I spent the next 6 weeks learning everything I could about this dark art of machine learning and trying it out for myself. After countless late nights glued to my laptop, I'd produced something I was pretty excited to share. This was an AI model that in a matter of minutes could listen to those hours of recordings that we gathered and teach itself to predict whether new recordings came from one of our healthy or degraded reefs. And better still, just like Tim's work, it showed that as we go from the beginning of the restoration process on the left here to something just a few years later on the right, the model found the soundscape of these formerly degraded reefs had returned to that of their healthy counterparts. This was an entirely new way to track reef recovery. It was also something that changed my perspective on AI. It was something I had admired from a distance, but it had seemed too technical, too mysterious for a marine biologist like me to start using. But it turns out this was just the beginning. For the next chapter in this journey, we wanted to take on something a bit more ambitious. This was to move beyond working with the whole noisy soundscape in this way, to instead trying to identify the individual sounds we hear within this. Now, typically, when we're developing an AI system that can do this kind of thing, we have to start by hand labeling thousands of example audio recordings for it to learn from and use some fancy supercomputer to train it with. And worse still, this process needs repeating for every new sound from every new data set that gets collected. So, how do we go from such a huge entry barrier to something anyone can try? Fortunately, it turned out one of the big hitters in the AI world was also interested in this challenge. This was Google's DeepMind team, who had identified bioacoustics as a field where AI could make game-changing breakthroughs. Now, sadly, I've not got the time to take a deep dive into the fascinating neural networks and other computational gymnastics we set out on together, but I will share one of the most interesting discoveries we made along the way, which was the secret sauce to tackling this problem actually came from the sound of something we don't hear in the ocean. It turns out we've been recording birds for much longer than we have coral reefs. We found DeepMind's model trained on nearly 3 million recordings of birds was pretty much the best thing out there at quickly learning to identify new reef sounds. But better still, if we mix together this enormous library of birds with the sounds from our reefs, alongside a host of everyday noises like dogs barking and fire engines, we got our winning combination. With a few other smart tricks thrown in, this model works with you as the human to rapidly learn to identify any new reef sound you throw at it and detect this across huge data sets, starting from just one single example of that sound. This is something I thought we were years away from achieving. To show you the difference it makes, I turn this back to those same reefs in Indonesia we'd studied before. Here, after just a few hours working with a model to label the purrs, pops, and grunts of fish together, it was able to detect over 100,000 more of these with high accuracy across 6 months of audio. That's 3,000 times more data for the listening effort that I put in. And yes, we still see the fish on our restored reefs here are back and singing just like those on their healthy counterparts. But what about saving the reefs that we still have? Well, that brings me to something we're taking on in the next step of this journey. That was the sound of highly destructive bomb fishing. This universally outlawed practice is a devastatingly fast way to kill a lot of fish that also inflicts untold destruction on the reef habitats where they live. But within the vastness of any nation's waters, we currently have no easy way to figure out where this happens and how often. However, sound travels much further underwater, meaning we can hear these bombs go off as far as 50 kilometers away. So, working with a team in a known hotspot for bomb fishing in the Indo-Pacific, we deployed one of these recorders and kept it listening for 6 months. With an AI model I developed for the team, they were able to turn each month of audio into just 4 hours for them to review. The results were pretty shocking. Across this 6 months, the team detected and verified over 4,600 incidents of bomb fishing from this one single recorder. Frightening numbers, but pivotal in getting that crucial evidence to reveal its true scale. Now, there are many hard yards ahead in taking this approach elsewhere and tackling the social issues that underpin this challenge, but I'm hopeful others will see the game-changing potential of this technology to help efforts in fighting this destruction. So, I've taken you on a journey to share just some of the ways we're using AI to help protect coral reefs. I hope you now agree with me. There are a lot of exciting things we can do with this new technology in the small corner of conservation I work in. But it's not just me doing this. There's a growing community out there. In our lab alone at UCL, colleagues are using AI to do everything from count wildlife in millions of images to listening out for bats just down the road on London's Olympic Park where our office is. By sharing the story of how this started for myself, I hope I can reach at least one other person. Maybe in this audience today, now wondering what else can we do with AI in the fight to save our natural world. Thank you.